Let's look at how we can do linear regression. Linear regression is when you want to get an equation to predict some variable. Let's start off with just one variable that we want to predict, performance. And this is, in fact, performance for a set of engineers that's graded on a scale from 1 to 4. And suppose that we have given them a test, a cognitive ability test, and we have a cognitive ability score for them. Now, we might want to do this if we want to be able to hire the best engineers. If we can find a correlation, a relationship between the test score and their performance, we could use this test to hire the best engineers, the ones most likely to perform well. So, and then we could use an equation that describes this relationship to help us make our predictions and hire the appropriate people. So our predictor, the variable that we're trying to predict is going to be performance, and we're going to use the cognitive ability test score to predict that. So the first thing we want to do is let's see if there's a correlation between the cognitive ability and performance. So we're going to do that first of all with the data analysis tool pack that you should have installed, and go to data analysis, correlation, okay. Now, the input is going to be this whole table, the two variables, starting at B3. I'm going to choose the second column with the shift arrow and then shift down arrow to get all the data. It's grouped by columns. Labels are in the first row. The output range, I want it to be over here. Now, I clicked on output range, but I need to put the cursor in here, and I'm going to delete what's there. And let's just put it down here and press OK. And let's round off some of these numbers. Go to Home, the number section, and go to Number. And we see that the correlation between performance and cognitive ability is very good. That's an R of 0.86, which is a strongly positive relationship between the test score and the performance. So let's make this a little bigger so we can read it. There, we can. Now let's calculate the equation that we can use to predict performance from cognitive ability. And the way that we're going to do that is a real simple way with a scatter plot and trend line and an equation for the trend line, our regression equation. Now we'll see later that we could do it with the data analysis tool, but actually this time we're not going to do it with the data analysis tool. So let's go to Insert. Let's put our, go into the table. Notice that it's a table because we don't have the option to make it into a table now. Let's go to a bar scatter chart. Click the first one and it'll take the whole table and it'll put it into a graph, and we see, aha, there's a strong relationship between performance and the test grid. But this is kind of weird, this chart. Let's see if we can fix it up. We first of all, those axes, we're only going from 100 to 140, but that's just a real small part. So let's go to chart, let's go to the axes and go to axes options. And for the bound, it's for the x-axis, it goes from 0 to 160. Let's change that to 100 to 140, because that's all the data that we have there. Okay, so that's good. And so that fixes that up. Now, if we go to, let's go back to the add chart element and do an axes title, primary horizontal. So this will be test score. And we're going to do cognitive ability test score. And then we need to have a y-axis label. So we go to add chart element, axis title, primary vertical, and we will call this performance. Okay, let's change the title to performance of engineers. Okay, now let's go back to the add chart element and add some grid lines, and let's go to, no, not grid lines. Oh, let's take off the grid lines. We don't need those grid lines. So I took off the horizontal ones. Let's take off the grid lines for the vertical ones. Okay. Now let's add a trend line. And I'm going to go to more trend line options to get to where we need to go. And it selects a linear one. Now we want to display the equation on the chart, and we want to display r squared. So I select both of those, and now I can move those to where we can read them. And we have a nice equation for our trend line, y equals 0.0741x minus about 7, and the r squared is 0.73 or 73%, and that means that 73% of the variability in the performance of these engineers is accounted for by the test scores, which means that there's about 27% that comes from other things. So this test score is a really good way of predicting their performance.